In this video we'll look at factoring out a greatest common factor, and you've done this before in earlier grades as far as identifying a greatest common factor. It's just now we'll add in a variable. So I'm going to write out a very easy example here just to illustrate what we're doing. So if we had 4x cubed plus 4x squared plus 4x plus 1, for example, let me make that 4, plus 4, we would, looking for the greatest common factor between all of these terms, we, one, need to look at the coefficients. These three are the coefficients, and the constant term. Those all go together. You could look at it as they are all numbers. So we want the biggest number that we could divide out of all of those. That's obviously a 4. And then look at your variables. So we have an x cubed, x squared, and an x. And because there is no x term here, we cannot actually take out a variable term. So the greatest common factor out of all of this would be a 4. If, for example, I didn't have this 4 over here, then we could take out a variable. We could take out an x, because that's the largest thing I can divide out of all of them. You can't divide an x cubed out of this and this, so we can't make it x cubed. It just has to be x. X can divide out of the x squared, and the x cubed. So once we've done that, I would be left with x squared plus x plus 1. Then you need to check your answer all the time and distribute that back in. So 4x times x squared is 4x cubed, 4x times x is plus 4x squared, 4x times 1 is plus 4x. And now it looks like it did before, so you know you did it correctly. So now let's look at some actual examples that you have on your paper. So negative 8x cubed plus 10. So I'll look at both the numbers, so the coefficient there and this constant term. So the biggest number that I can divide out of a negative 8 and a 10 would be a 2. And then I also want to go ahead and take out that negative if it's on the leading term. So I'm going to take out a negative 2. Then I'll look at my variable portion. I have an x cubed here but no variable here. Therefore my greatest common factor can't include a variable. So once I divide this one by a negative 2 and this one by a negative 2, I would be left with 4x cubed and minus 5. So we want to check that and make sure we end where we started. So negative 2 times 4x cubed would be the negative 8x cubed, so that's right. And then the negative 2 times the negative 5 would be a positive 10, so I know I did it correctly. So this would be factoring out the greatest common factor of negative 8x cubed plus 10. So this is equivalent to what we have here. They're both equivalent. It's just this part down here has the greatest common factor already pulled out. Okay, the second example here, we're going to do the same thing. We're going to look at the coefficients and any constant terms. We don't have constant terms here, so we're just looking at coefficients. So I ask myself, what's the biggest number that I can divide out of 12 and 9? That would be a 3. So that's the biggest number that I can divide out of 12 and 9. And now look at your variable terms. I have a k squared here and a k cubed here. The biggest variable term I can divide out of those is a k squared. Not a k cubed, because I can't take k cubed out of k squared. So k squared is the biggest I can do. Okay, now write what's left. So now what's going in here is after we've divided out a 3k squared. That's the way you're thinking about it in your mind. So think about it this way. 12 divided by 3 is 4, so that would be left over. K squared divided by k squared, that cancels, so this first term is just a 4. And then we'll be subtracting here. So 9 divided by 3 is 3. K cubed divided by k squared is just k. So 4 minus 3k in parentheses. This is equivalent to this. We always want to distribute back in and verify that we did it correctly. 3k squared times 4 is 12k squared. Check. That part's right. 3k squared times negative 3k is negative 9k cubed. So that checks out as well. So this is equivalent to this. Greatest common factor would be 3k squared. Let's look at one more example. All right, 14. This would be our third example. So again, we look at all of the coefficients and constant terms. We don't have a constant term here. We just have coefficients of 10, 14, and 16. So the largest number that I can divide out of all of those is a 2. So that's going to be part of my greatest common factor. Now look at the variable terms. I have a to the fourth, a cubed, and a squared. So the biggest that I can divide out of those is an a squared. I can't divide out an a to the fourth from that or that. So a squared is as big, the greatest common factor I can use for the a portion. So then look at the b's. So b to the first, b squared, b squared. So b to the first is the greatest common factor that I can pull out of b, b squared, and b squared. So there is my greatest common factor. Now in parentheses I have to write what's left. This is not the answer. This is the greatest common factor, but it's not factored out unless I write the rest of it here. So 10 divided by 2 is 5. That's this 10 divided by that 2. A to the fourth divided by a squared is a squared. B divided by b cancels, so no b's left there. Plus this 14 divided by 2 is 7. A cubed divided by a squared is a. B squared divided by b is b. So this term, after you take out the greatest common factor, you're left with 7ab. Now this one. So this 16 divided by this 2 is plus 8. A squared divided by a squared cancels. And b squared divided by b is just b. So altogether, this is equivalent to this, but I have taken the greatest common factor out in this form. So check it. So we'll distribute back in. So I'll write this down here in this pink color. So 2 times 5 is 10, a squared times a squared, a to the fourth, and then b. Check. That one works out. Distribute here. 2 times 7 plus 14, a squared times a cubed, b times b, b squared. Check. Distribute here and double check. 2 times 8, 16. A squared times no other a's is just a squared. B times b, b squared. Check. So we know we did it correctly. So this is your answer after you have factored out the greatest common factor. So this is equivalent to this.